This video covers enhancements to Simcenter Flotherm MCAD Bridge version 2304. You can still access MCAD Bridge in the same way as before, either through the separate application from the Start menu, or if you want to transfer geometry to a Flotherm project, then using the same cog icon from the Flotherm menu. The first step is to import some CAD geometry, and at this point we see the first changes. In the external menu, there is now more connectivity to other CAD software with the addition of import of NX, Solid Edge, Parasolid, JT, PLM XML, and XTXML. MCAD Bridge no longer imports STL or DXF formats. For export, we can now export Parasolid, JT, and PLM XML formats, but no longer support SAT or STL export. Once you have imported your CAD model, the first changes you see are in handling instances. These are multiple linked CAD bodies represented with the icon of a link with a cog. Each instance name is appended with the number of the instance. If you act on one instance that is linked, you will act on all. So you can replace one here with a single cuboid and all of them are replaced with a single cuboid. But you may not want to do that and may want to break the connection. To do that, use the Make Independent tool with its broken link icon. This makes the selected instance independent, but the other instances remain linked together. You'll also notice when you select a body that the property sheet has been updated and now includes data for the centre of gravity position and the surface area. You can select faces and get data for the face in the property sheet too. To swap between body, feature, face and edge selections, right-click in the GDA off the geometry and select the option you want. The Tools menu is where you'll find all the different ways you can take the CAD and turn it into Flotherm realised objects, and there have been some changes. Following a customer survey, it was determined that Decompose and Dissect were rarely used, and so they have been removed from this version of MCAD Bridge. But there have also been updates to the remaining tools. The first tool option to have an update is the Global Simplify tool. Here we have added the option Delete Cylindrical Holes. This will delete any cylindrical holes up to and including the specified tolerance. So you can select a hole of the size you want to delete, find the radius via the property sheet, and set the tolerance to delete all holes this size or smaller from the geometry. Illustrating NX connectivity, here is the CAD geometry shown in Siemens NX. I can save the geometry in NX default format, or I can of course export it as another file format that will work with MCAD Bridge. Moving to MCAD Bridge, I open the CAD geometry in a quick step. I'm now going to use this part to demonstrate updates to voxelization. For voxelize, there are now options for using faceted geometry and the number of ray directions. Previously, the number of rays was fixed at 1. More rays increases the likelihood of the voxelized solution's accuracy and reduces the likelihood of gaps in the result. A ray is used to determine what is solid geometry, but errors occur if the ray is parallel to and intersects an edge or face. Using multiple rays in different directions helps to eliminate these errors. Here we can see the difference in using 1 ray versus 3. Faceted geometry is commonly used to display models and will allow for good representation, especially for curved geometry. A spherical surface on the geometry will have no vertices to guide the voxelization mesh, and so the details of the geometry can be missed. Using faceted geometry means the facets' vertices are used as key point guides for the voxelization mesh. Adding the faceted geometry option improves the geometry representation even further in this case. It is worth noting that voxelization has had a significant increase in speed. Even though using 3 ray directions is slower than using 1, this new version of MCAD Bridge is much faster than previous versions. So while in this example the 3 ray option took over 3 times as long as the 1 ray option, the 2 minute and 28 seconds is still 57 times faster than the previous version using just 1 ray for voxelization. The other tools that will be familiar to you from previous versions, like single object, local simplify, split body, etc., have had no major changes. There are some new tools, however. Separate disjoint bodies can be helpful if you have imported geometry where a single body exists in the tree, but there is really a separation. You can perform an operation on the whole body and it will be applied between the two entities. For instance, here I could replace with a single prism and any disconnect is ignored. But it may be that they are supposed to be separate bodies, but for some reason they have been imported as one. The Separate Disjoint Bodies tool will create an assembly with two individual bodies. It is then possible to operate on them individually at body level or as a whole at assembly level. The last new tool is the Power Select tool. This is a simple to use way to find and select parts of the geometry that have particular characteristics in common without having to go through the whole geometry tree. The first option of Select Holes will select all the holes in the model irrespective of the shape of those holes. Cylindrical holes will allow you to select all the cylindrical holes in the model regardless of size. Or you can refine on diameter size that you specify. You can also select a hole and then select all other cylindrical holes that are equal in diameter or less than and equal to the hole that you've selected. Blend allows you to find and select based on radius dimension. You can specify a radius or select one to match with. Faces will allow you to select all planar, all non-planar, or all coplanar faces. With bodies, you can select via the volume size, either a volume that you specify or to match your selection. Or you can search via the name of the body. You can use a partial match to select many, or use an exact name match. The name match is case sensitive. Once you've worked on your model and you want to transfer to Flotherm, you can still do so either as you work, so any realised parts and assemblies will be transferred, or with the model as a whole. Voxelized geometry is transferred as a lightweight assembly. You can switch this option in Flotherm as desired. Now that MCAD Bridge can import XTXML geometry, it is possible to export geometry from Package Creator to Flotherm via MCAD Bridge. When importing the XTXML file format, geometry will be realised as Flotherm geometry wherever possible. At this time, only the geometry is transferred, not the material or thermal properties. Once your detailed package is realised as Flotherm geometry, you are free to use it like any other, including creating BCI ROMs. Thank you.